Hello again and welcome to another video from Berkshire Guitar Amplifier Repairs. We have a Fender Pro Junior up on the bench today. The customer says he hasn't used it for a few years, and when he came to use it the volume was lower than it should be and more distorted. It distorts more quickly than it should. He put a new set of valves in, 2 EL84s and 2 ECC83s in this amp, and that hasn't made any difference whatsoever. So I think the first thing I'll do is switch it on and see if I agree with him, and then we can have a look and see if we can work out what's going on. It won't be valves, so it must be something else. Right, here I've got it plugged in and a guitar in. Let's turn it on. Light comes on okay. What should we say, about 5 on each of the controls. And let's see if we can hear anything. I'll just strum the guitar. Okay, I'm getting a reasonable level, clean signal there. A bit of distortion on the bass side. Not sure how loud this thing's supposed to be. He said it was very loud. Anyway, let's turn it up a bit. That's quite distorted there. Yeah, very distorted. Okay, well, something's wrong. I don't think we can do much without pulling the chassis, and that's not difficult on this amp, just these 2 screws. So let's get the chassis out and see if we can see anything on the inside. Might be low HT, for example. That would be one of my guesses. Okay, I've taken the back off, left the chassis in for the moment. I don't think that we actually need to remove the chassis on this amp. I've had a good look around with the eyeglass and there's nothing obvious. As you can see, there's not a lot to this amp really. A couple of preamp valves, a couple of EL84s. The HT caps don't look like they're leaking, there's nothing obvious there. It all looks incredibly new and clean really. So I think the order of the day will be to measure the HT. I think I'll just put a meter on the HT here and see if we've got anything like sensible volts. Then I will put a bias probe on these EL84s to see what they're doing. Are they drawing enough current? Do they have HT on them? That's my preferred route. Let's give that a go then and see how we get on. Right, we're set up to do some measurements here. You know, after you've done anything for a few years you get a gut feeling, and my gut feeling on this amp is output transformer. I don't normally go for that, that's the least likely thing to be wrong with an amp, but there's just something about this that makes me think maybe the output transformer's gone low volume plus distortion. Anyway, that's just my prediction. Let's have a little measure and see what we've got in the way of HT on these caps here. Where are we? Oh, it's not on. It always helps to have the amp on, I find. Oh, we've got HT there. We've got 350 on that cap. 325 on that one. 350. This is all looking good on the HT side. 350. That's all good. I'm going to do what I said I was going to do and put a bias probe in on one of these tubes. I just want to see what's going on with the tubes. Are they pulling any current? What's the bias current like? Obviously if the bias current was right down to virtually nothing, that would also cause the problem. They feel equally hot, so it's not a one tube out situation, I don't think. Let me grab my bias probe. Nice little bias probe, this from Euro Tubes. I recommend it, and this is the EL84 version, which is a nice one to have. Obviously I've got the one that does the bigger basses. So I'll plug that in there and plug that in there. One of the slight disadvantages with this probe is that this is a bit tall, and so sometimes you get into a situation where you haven't got enough room to put the probe in. Anyway, let's see what happens here. Okay, look, we've got HT, which is perfect. Current's coming up. I want to see that get up to, oh, that's getting up, that's fine. Aha, so do you see where we're going with this? We've got HT, we've got a nice current through the valves. I obviously will check this. In fact, why don't we just do that? So we've got 27 milliamps through one tube. It could be this tube is down or something, so let's eliminate that. Pop that one back in there. I'm not sure which output transformer this takes. It may be the same as the Fender Blues Junior or similar. Anyway, I've certainly got an output transformer I can temporarily tack in there to see if this is indeed our problem. Right, so we're now on the second valve. Let's turn on. It was already hot, so that's why it's coming up. And again, HT, and then perfect current through the valves. Alright, well, let's have a little think. I'll just move this bias probe. The output transformer comes up here. Look, there are 3 cables here. One will be HT, my guess is the red one, and these will be the anodes of the 2 power valves here and here, and the other 2 wires on the secondary will disappear off to the speaker output over here somehow. I don't know, I can't see where they come immediately. Maybe that's these 2 here, possibly this red and green here, black and green, I beg your pardon, coming up through there, almost certainly, in fact, and going off to the output jack. So it's fairly easy for me to pull these and stick a Fender Blues Junior transformer on there, put my house speaker on the output of the Fender Blues Junior transformer, and see if it all sounds a bit louder. I think I'll do that. Let me just quickly check. I mean, I'm 99% sure this will be the HT, the red here. So we've got 347 on there, so I'd expect these to be a bit lower, this blue and black here to be a bit lower, so 344 and 344, yeah. I'm pretty comfortable that these are the 2 anodes. One goes off to this ribbon here, which goes to this EL84, the other one goes off to this ribbon here, which goes to this EL84. So I think that's job done. Right, I will go and grab my Fender Blues Junior output transformer and see what happens when we attach that. I've just had a peek underneath here, and the output transformer looks quite like this. This is the Fender Blues Junior one. And look, interesting, isn't it? We've got red, blue and brown, just like we have here. Red, blue and brown. I thought that was black, but it's actually dark brown. And then on the secondary side we've got green and black, which is green and black going off to there. So I'm pretty confident that this uses exactly the same output transformer. So I'm just going to pull these wires here, put these on here, hang a speaker off here, and see what happens. To do that, the very first thing I'm going to do is to unplug it from the mains. And I'm also just going to measure the HT voltages here, make sure things have come down nicely. No nasty HT hanging around when I grab hold of these. Right, that's all good, happy with that. So now, using a pair of pliers, we can just pull these. Little sharp tug there. I suppose I ought to make a note of these. Yes, I think I'll just do that. I'm always quite sort of thorough about making notes on things. You think you'll remember, but you flipping well don't, I tell you. So I'm going to go blue goes to CP1, brown goes to CP3, and red goes to CP2. There we go. Can't forget that. So we've got the blue off, here's the brown coming off now. There, and here's the red coming off. There, that's good. I can measure the resistance here at some point, but I won't get involved in that. I just really want to eliminate the, or confirm that it's the output transformer. So here we go. Brown to CP3. Blue to CP1. Red to CP2. Up there. Right, I've just heard another customer arrive, so I'll just turn off the camera and we'll pick this up again in a moment. Okay, just to show you what I've done, I've tacked in the primary there. Secondary I've got going off to my house speaker. I've turned it on and we have no improvement here. Very surprising. Listen to the distortion on that. Like going through a distortion pedal. Okay, well, not the output transformer then. I'm going to have to get technical with this amp and see if the distortion is coming from the preamp stage. In other words, start getting a scope on here and see what's going on. This is turning out to be a more difficult fault than I thought. Okay, little bit of an update. The sound came back full volume for about a second, then went away again. Now it's in a mode where it's quite, I've got a tone going in by the way, but it's quite grumbly. It feels like it's about to break through or about to go lower level. Now I've done a fair bit of tapping around here without much. Don't know whether you can hear that, kind of wants to break through, but isn't quite. I've tried all the usual suspects like these ribbon cables. I've given the board a good tap. That's annoying that because it came back full volume and then just cut out again. Kind of implies it's a connection or dry joint or something. Seems a bit sensitive around this V1. Playing. I want it to cut out or come back. I'm flexing the board here. That normally shows up any dry joint problems. There's another little board under here which is the valve board. Hear that coming and going there? I'm just going to try a bit of freezer. I'm not hopeful here, but I'll just try a bit of freezer spray around this section. That can sometimes cause something to spring back to life. Nope. It's not components getting warm. Ooh, see that does come and go slightly there. I haven't changed this preamp valve. I mean, I do trust that he's put a new one in. Let's just pull it. I don't think for a minute it'll be the preamp valve. Okay, maybe that was a faulty one. Still low level though. Okay, well I think we'll have to have another think on this. Well, good afternoon. It's been 24 hours since the last clip, and well, I just want to say something that about every 50 amps or so I get one which is pretty difficult and challenges me. I mean, all amps challenge me, it's just that you get a particularly tricky problem, and this amp is turning out to be one of those. I've spent quite a few hours since I last was with you trying various things, and I've been kind of running out of ideas. I think it's quite useful to see how amp techs can struggle sometimes. It's all very well having a nice slick video where everything's just cut together and you go straight to the fault, and you cut out the 3 hours you spent messing around down some blind alley and making it look like you're really, you know, the top man. But I think it helps to see. I certainly enjoy watching other amp techs struggle through a problem. And the text or emails I get quite frequently is from another amp tech saying, why didn't you check C42, or hey, you missed R29, or why didn't you do this, or why didn't you do the other. I always laugh at those. I mean, they of all people should know better than to send a message like that, because it's an art and a science, amp diagnostics. You have a hypothesis and then you follow your hypothesis through until the evidence tells you that you're on the wrong trail, and then you try another hypothesis, and that's how you do it. Of course, you've got experience that it might be this or that or the other, and those are the hypotheses you go for first of all, of course. But many times I've been down a complete blind alley and convinced that I'm right in terms of what's wrong with the amp, but it's turned out to be something different. So anyway, I thought that might be useful information to you. So on this amp here, there's something weird going on because the signal's coming out okay out of V1. This is the phase split of V2, and the signal out of there is, again, I think, you know, pretty good. It squares off a bit at a lower peak-to-peak voltage than I think it should, but anyway, that's that. On the output side, if I put the scope on the secondary of the output transformer, I'm getting this tiny little, well, 5 volts peak-to-peak virtual square wave with hardly any input going into the amp. But the sine wave on the anodes, again, looks reasonable, but it's lower level than I would have thought. It's kind of 50 volts peak-to-peak instead of, I don't know, a couple of hundred. Again, if I hadn't done anything on this amp at all, but just looked at that output signal, I would say output transformer. And funnily enough, that's the very first thing I came up with, was the output transformer. But I've actually swapped it twice now. I know it's ridiculous. I did it once, but I thought, this is so much like the output transformer. So I swapped it again, but exactly the same business. So what I'm thinking now, I slept on this amp, and very uncomfortable it was. And sleeping on an issue like this always helps, I find. If it starts to get late at night and I'm not having any luck, I go to bed and call it a day. It's taken me decades to learn to do that. And I wake up in the morning, I've usually got 1 or 2 new ideas in my mind. Now, follow me through on this. This is the idea I'm going to have a go at now. Here are the output tubes, EL84s, and here are the plates, the anodes, there and there. As you know, one goes up and one goes down. It's a kind of push-pull arrangement. I haven't shown you on the schematic, but here, hanging off these 2 wires here, is the primary of the output transformer. So that just goes to the primary there, and the center tap of the primary goes to the HT. So I'm looking at these components here and thinking, well, these are right across the primary here. If there was something wrong with that capacitor, if it was short circuit or something, we would have a problem here. We would effectively be slugging the primary of the output transformer with a 270 ohm resistor, and that would cause all kinds of problems. In fact, it would look exactly like an output transformer problem, which this does. So I'm wondering about this C11 here. Now before I have actually just put a meter on there and it seems okay. In other words, it's not short circuit. So I was a bit disappointed about that. But what I'd like to do now is to put some decent voltage across that and see if that breaks down under load. The way I'm going to do that is, as I say, these go to the output transformer. So I'm going to pull the output transformer wires again. That's this blue and this brown here. So the output transformer is disconnected. So there's nothing here and nothing there. And I'm also going to pull the output tubes out, take them out, so there's nothing here and nothing there, leaving just these components here, which I think you'll agree there's nothing hanging on to those. And then I'm going to put a mega, I'll tell you what that is in a moment if you don't know, just across there. And I reckon I can do that by putting it across this terminal here and this terminal here once I've disconnected this blue and this brown. Here's the two components here. There's R26 270 ohms there. Let's see if I can just zoom in a little bit so that you can see a bit more detail there. There you go. So here are the components here. Where are we? Lost them now. There. R26 270 ohms. By the way, I've measured that and that is 270 ohms, so that's okay. There we have that disc capacitor there. C11, 2200 picofarads at 1 kilovolt. And I've put a meter on there and it's not open, it's not short circuit, it seems kind of okay to me. Sorry about all the talk, but I think it's quite useful to follow through on fault finding process when things get tough, which they certainly do from time to time, I can promise you. I've spent the best part of a day, a full 8-hour day on one amplifier before now. I don't know if you know about the conductive printed circuit boards on the Marshall TSL and DSL. The boards are actually conductive so that the tracks conduct one to the other and you get this leakage and the bias runs away. Well, I'd never heard of that. It's obviously quite well known, but when I first started out a few years ago I hadn't come across it, and I spent a full day trying to work out what the heck was going on and actually narrowed it down to the fact that that track must be conducting across to that track through a printed circuit board. And I thought, well, that's ridiculous, that can't possibly be. But then I phoned another amp tech friend of mine and said, oh, is that a TSL? Yes. Oh, don't you know about the conductive boards on Marshall? No, I didn't. Oh yeah, no, they had a batch of... So I spent a full day and I was tearing my hair out on that repair. Anyway, that's neither here nor there. I've had many occasions like that. So now look, I've pulled those. What else? I'm going to pull the valves now. There's the output tubes gone. Now I reckon that from that tag to that tag we've got nothing now apart from R24 in series with C11. So we're right across there now. Now let me just check again with my meter. Just my ordinary meter, and of course we shouldn't have anything here. We shouldn't have, because of the capacitor, it should be open circuit. So I'm going to go on to, doesn't really matter, 200k range on the meter. Right, so we should have a kind of an open circuit situation between these two tags now. Oh, right, well I thought I'd measured on that capacitor. Maybe I wasn't getting on there properly earlier on, but that's... We've got ourselves a problem there. Well, unless I'm being silly here, there's nothing else in circuit apart from, am I on the right? Yeah, I am. Apart from R26 and C11. So it's looking like C11, even though I thought I'd managed to get on there, is see if I can actually get on the... yes, it's quite difficult to get on the actual leads. Is 1k. Well, that's the issue. This is C11. C11 is the problem. Oh, well, that's great. That's actually brilliant. I'm delighted about that because I've been fretting on this amp. Let me show you what I was going to do, because I think again you might find this quite interesting. Right. Okay, I've got what's called a mega here. You may or may not be familiar with it. It's for testing insulation, actually, to make sure that something really insulated. It's all very well putting a 5-volt meter across something and reading an open circuit and saying, oh yeah, that insulation's fine, but of course you want to know if it's going to break down under high voltage. This Mega puts out 500 volts and measures the resistance. If I press the button and the terminals aren't connected to anything, absolutely nothing happens. You don't get any reading whatsoever. And if I short circuit the connections like that, just shorted one to the other, then that will obviously read I'm hoping it's going to read a short circuit, and indeed it does. But this is putting out 500 volts on these terminals. It's good for testing high voltage capacitors. Do they break down under high voltage? But I was going to clip one side to here and one side to here. So now we are putting, let me just show you on the schematic. This is all learning stuff. I'm just hoping you're finding it interesting. So now we're putting 500 volts from here to here. That's a 1 kV, a 1000 volt capacitor, so that's fine. And we should get a complete open circuit because no current can go through that capacitor. That capacitor will block all DC, so that should be an open circuit. If we read anything at all on the meter, then this capacitor is breaking down under the high voltage conditions. But we know it's broken down already because we did it under low voltage conditions. But let's just have a look, see what happens. So there, okay. I'm sure they've got a loose connection here or something, but anyway, there we go. And then it drops down again. I noticed that it comes up and shows a fault condition and drops back down to the no fault condition. So maybe that capacitor is kind of, half working, half not. Sometimes it breaks down, sometimes it doesn't. Anyway, I am confident enough now to say that I want to change C11 and hope that gets us out of trouble. Right, now what's involved in doing that? Let's have a look. Let's get rid of this. Very useful thing to have, a Mega. They're not very expensive. This is an old one, as you can probably see, but you can get them electronic now on eBay or whatever for not very much money. Now what's involved here? Okay, so well, we want to get the board out and up that way. That might actually do it, if we take the controls off, take the 4 screws out, I think we can probably, you're going to have to sort of, yeah, we have to get rid of these secondary, these leads, flatten those out the way for the board to come past, and I think that will probably joggle past there. Alright, let me do that. I will meet you again when I've got the controls off and these screws out, and then we'll see how we get on with joggling the board out. Okay, that didn't take too long. Just took the screws out, took the knobs off, and just one nut here. So now I'm going to try and joggle the ball out far enough away from here so that we can swing it up past here. Always a little bit of a tricky issue. Needless to say, the amp is off and discharged, and we have to get it past these cables here as well. So let me pre-bend those out the way. Okay, it's coming. Got very long pot shafts here, of course, to somehow get past. Oh God, as ever, they only just go. I think Fender do this deliberately. Alright, there we go. Oh, now just be careful, I've fallen foul of this before, this LED here, and I've popped the wires out of there, and that makes it very difficult to fix. So I'm just going to take this cable tie off here. There we go. Give us a bit of leeway there, and this is going to come out. Might come out just enough for us to do what we want to do. I think it will. Okay, so C11, I'm going to try and grab hold of it with my fingers whilst desoldering it from the other side. Before I do that, have I got anything remotely like it? What have we got here? 2200 picofarads at 1 kV. Let me go and see if I've got a replacement before I get too enthusiastic. Okay, great news. Some months ago I invested in a huge pack of 3 kV HT capacitors, and there are about 20 different values in here, each in their own little poly bag. And I've just had a rootle through, and good news is I do have, well, one of the bags contained a 2.2 nanofarad 3 kV capacitor, so we're going to pop that in there. That's the plan. How easy it will be, I don't know. So let's see if we can get the old one out first of all. And to do that, I'm going to grab hold of it. I'm not sure I can do this without sticking my head in front of the camera. In fact, I can't. So just trust me, I'm going to grab hold of that, get the soldering iron in, and just pop that capacitor out. So let me do that, because you don't want to watch the back of my head. Right, that came out without too much drama at all. And I will now just pop in a new one. He says, put my head in the way here as well. There we go. Right, that's the new one in. We'll just bend the leads over on the back a little bit just to stop it dropping out. Okay, I'm now going to solder that in, and again, there's no way I can do that without sticking my head in front of the camera, so I will just bend the board back and solder that in there. Right, again, that was quite straightforward, putting that capacitor in. So let's now put the board back in. Same process, just very delicately. You've got to watch these interboard connectors here, they're a little bit delicate. Don't like being stressed around. So I'm going gingerly here. Not even close to going back at the moment. Let's see, there we go. Putting quite a bit of force on this board to get it past there. There we go, that's back. Okay, there's the board back. And we just have to hope we haven't overstressed these connectors here and broken one off. It's a little bit of a problem, that is. Right, let's pop one screw back in to secure it. Then we'll have the board located. I'll be delighted if this is a fix, because I've been quite a few hours, maybe 5 hours on this amp, and there'll be people shouting at the screen now saying, oh, you should have gone for C11 straight away, those high voltage capacitors are always going. Yep, but I didn't have that hypothesis in my mind at the time. Okay, so of course the only reason any of us amp techs do this is for the fun of solving a difficult problem like this. There's no money in amp repairs. You can't make a living at it. Most of the amp techs are kind of enthusiastic hobbyists who have it as a sideline. Yeah, it gives you some holiday money or whatever, but you couldn't possibly, well, I suppose you could make a living at it if you did it 8 hours a day, 6 days a week, and you charged double the amount I charge. Yeah, you probably could. Not a very good living. But we do it because, well, I shouldn't really say we at all, I should say I. I do it because, actually there are several reasons. One is I enjoy the technical challenge. It's great to be able to use your skills in life. So there's just the joy of doing that. The second is it's a service to the local musicians, because there aren't many amp techs around. There are hardly any people doing this, and you have to end up throwing your amp away if you can't get someone to fix it. And the third reason is kind of environmental. I hate to see amplifiers thrown into landfill because no one knows how to change a 3 kV or 1 kV capacitor. So, you know, there's 3 reasons. Plus, I don't know what it is about musicians, but they're a flipping great bunch of people, musicians. I have hundreds of people coming into this workshop with amps, and do you know what? I've never had what I would call a funny person or a slightly off person. They've all just been great guys. I mean, they are guys, I have to say. Yeah, so it's good, really. That's why I do it. I suspect that's why the other amp techs watching this do it as well. And it's also nice sharing your knowledge. There's no, I don't make any money out of the YouTube channel or anything like that. I haven't got any merchandise or any of that stuff. It's just great. I mean, I've been helped out so many times by YouTube videos on people doing it just because they have the love of it. Okay, so we are in good shape here. These are all back. This is a feedback resistor here. It comes right from the output and goes right back to the beginning of the circuit. It's a negative feedback. I won't pop that on at the moment. I took that off thinking that might be affecting something, but it doesn't seem to be. So I'll put some cable ties around here eventually, but I think, why don't we pop some power tubes in live on air and see if we get any joy. I'm quietly hopeful. There we go. I'll plug it in. Now, just before I turn on, we've got speaker. I think I'll just put the speaker straight in at the moment. It's going off to my oscilloscope and various things. So let's put the speaker straight in. We'll have a guitar plugged in. I'll be able to tell straight away if it's working. It'll sound completely different to how it did. I haven't put the knobs on or the jack nut on. Let's just see if this works. Alright, let's do a double check before we get too clever here. Red, yes. Blue, brown. They are in the correct position. I've got the feedback disconnected, but I'm not worried about that for the moment. That won't affect dramatically the amps working. We have power valves in, we have preamp valves in, we have the speaker connected, we have a guitar plugged in. Yep, I think we're good to go. Turn it on, let it warm up, and see if where the volume's down a bit at the moment. Good. Okay, I can immediately hear no comparison. That's loud, and we haven't even got the volume. That, my friends, is a fix. And no one is more happy than me, because I've been 5 hours and 1 sleepless night on this amp. Again, the other amp techs will know when you go to bed with a problem in your mind, you can't get to sleep because you're thinking, did I check R45? Why didn't I check the voltage on there? Why? You kind of mull it over in your mind. I've got up several times in the past, got up at 2 in the morning and thought, I'm just going to check R55. I know, I need to get out a lot more. Right, so we are in business there, my friends. I'm absolutely delighted. I'm going to put the furniture back on the top. I'm going to put the feedback resistor back onto there, and I'm just going to check the bias is okay. I might do that with you, and we're good to go. Okay, I think this might interest you. Excuse the rat's nest of leads. It's just the probes from the Mega connected to some croc clips and going to our capacitor that I actually took out of the amp. And watch what happens when I press the button. We have a virtual short circuit on that capacitor. Also, I don't know if you're going to be able to see that. Let me see. Sometimes you can, sometimes you can't. Just hold this. I'm going to try and zooming in. There's a little burn mark on this leg of the capacitor from the back. So let me see if you can see that. Yeah, I think you should be able to see it. It might be a bit out of focus. You can see that little burn mark on the top there. So this capacitor has failed. 1 kV, not enough Fender, but a 3 kV in. So I'm absolutely delighted. 100% fix and a 100% diagnosis of that component there being faulty. Good. So a final check on the amp. We have Now put the furniture back on the top and the nut back in. Incredible how unstable that jack was without the nut. I plugged the guitar lead in and this jack socket was wobbling all over the place. So that's how those become desoldered if you don't have the nut done up tightly. I've got to put some cable ties on here, look, to tidy this up. I put my feedback lead back. So we're all good to go. I'm going to turn on and have a look at the bias current next and make sure that that's exactly where we want it to be. Okay, the amp is on. I've got the bias meter connected, and the correct bias for 330 volts on an EL84 is 25 milliamps. So this is a little bit on the hot side. I think I might just bring that down a bit. At the moment I have absolutely no idea how to do that, so I'm going to need to remind myself it's going up to 30 milliamps, so that is a bit too hot. If it was a milliamp or two I wouldn't mind, but it's 5 milliamps hot. So let me go and grab the bias manual and we'll see. We'll have to change a resistor on the board somehow. It doesn't mean taking the board out. We'll bring that back down to 25 milliamps. Okay, I've just had a look at the schematic, and the bad news is they've got a kind of weird ass way of getting the negative minus 10 volts bias voltage here, and they do it by this, to my view, rather kind of shonky system of taking a sniff of the HT. Don't forget this is like 130 volts AC here, and taking it through this capacitor and just allowing enough of it to go through to rectify and smooth using these capacitors here to get the minus 10 volts. It's never a very satisfactory way, but of course it saves them having a separate winding for the HT, which saves £1.50 on the transformer cost, which, you know, well, I'll say no more. Now the only way to change the bias on this is to change the value of this resistor here, this R29. Changing that does a certain amount, but it's not very much, and changing this does nothing. So the bad news for us is decreasing the value of R29 increases the bias current. That's not surprising because it means we get less negative voltage here. If you like, more of it goes to ground. So less negative bias voltage, this goes down to say minus 9 volts or something, means more bias current through the tube. So we need to increase the value of R29 from 15k. I don't want to take the board out again to do that, and I've found a way to do it without taking the board out. So there's R29 there. It's across this capacitor here, C13. So that point's connected to there, that point's connected to there. Where are we on the schematic? R29, look, it's across this 10 microfarad capacitor. So I'm just going to put a 22k across that capacitor and just chop one leg of that out. And that will be perfectly satisfactory. So why don't I do that now and see how close we get with 22k, or whether we've kind of overcooked it. Okay, well the answer is that we've overcooked it. I cheated a little bit and put my resistance decade box on the job. Let me zoom out a bit. So I've just dialed in 22k and we've got 15 milliamps. So 22k is not enough. So let's go down to, let me see, what was it originally? 15k. Let's try 18k then. It's 18k. Okay, yeah, that has come down a bit. It was 30 if you remember. So 19k. Oh, it's quite sensitive. We're after about 25 milliamps, so you know what, I'm tempted. 27, 26.9. I'm happy with that actually. 27 milliamps, 18k. I think I'll put an 18k in there and call that job done. Right, there you go. You can see I've clipped R29 and just bent it out the way, and I've tacked an 18k across C13, which of course is exactly where R29 went. It was just easier to solder onto C13. Now purists watching this are going to be texting me and emailing me saying, you can't do that, you should take the board out, all that kind of stuff. I promise you that that joint there will be good in 30 years from now. There's nothing going to go wrong with that. And there's no free lunches in maintenance. To do that properly, in inverted commas, I have to take the board out again. Okay, so first of all, that's another £30 on the bill for the customer, and we're stressing these ribbon cables here, so possibly building up some problem in the future. So you create a problem here to save a problem there. You know, you have to take a view on these things, and as I say, that is a perfectly good repair. Nothing is going to go wrong with that solder joint, I can assure you. That'll be good. So I'm happy with that repair. We've got exactly the right, or very close to the correct bias current, and we're good to go. So I'm going to put this amp back together and consider that job done. Well, there you go. Every now and then I get an amp which really does challenge me, and this one did. You get an idea in your head about what's wrong with it and follow that trail, and it leads to a dead end, and then you struggle to find out what really is the issue, and it all turned out to be this little 5p component here. Well, we got there in the end, and I was very pleased to have fixed it, because it had been kicking around on the bench for the best part of 24 hours. And I hope you enjoyed the fault finding process, because that's what it's all about, really. Learning to have a hypothesis, follow it down, see if the trail goes cold, and then try another hypothesis and see if that works. Well, thanks very much for watching. I'll catch you on the next video.